$3.2 billion project. Is that one of the biggest projects you've done, or is there anything that tops that?
Yes, it's the largest project I've worked on, certainly monetarily, and to some degrees, even the components. But a lot of the jobs over the years have been very large, just like that, but not, like in today's money, they would be similar.
So, welcome to the SGS podcast. This is our first episode, and we're here with Ken Butler, Stuart, and Siva, and we're excited to get into it today. Ken is AECOM's global director for complex bridges. He's responsible for overseeing over 600 engineers on global projects. He's over 39 years of experience, so he's worked on a number of really notable projects, and so we're really excited to talk to him today.
Happy to be here.
Yep, we really appreciate it. So Ken, one of the things that we really wanted to ask you was, what was the most unique project that you've worked on? What made you step outside of the box in your career the most?
Oh, that's a good question. There's always a defining project probably in everybody's career. Mine was
Yeah.
Senator Roth Bridge in just south of Wilmington, Delaware.
Okay.
It's a cable stay bridge over the Chesapeake and Delaware Canal, um, owned by the Army Corps of Engineers, but it was built by DelDOT, Delaware DOT. So that project back in 1989 to 1991, I worked on the design of it. And then in those days, because of the technology, we always put our design engineers in the field during construction to help the contractor build it. Cable stay technology was very new at the time. It was also precast segmental bridge. Segmental bridges were relatively new technology. So I spent 4 years in construction. So six years of my career were spent in Delaware. And I mean, just to give you an example, the person who was leading Federal Highway, Mike Britt, is now president of Majeski Masters. All the people that I met there went on to do great things. I worked with those same people on DelDOT's second cable stay bridge 25 years later, over Indian River,
Yeah,
in
yeah.
Rehoboth Beach. So
Yep.
that for me was, I made a lot of contacts in the industry that I still have today, at least the
Yeah.
ones that haven't retired yet. So.
Wonderful.
You mentioned it was built by DelDOT. Actually, or that a contractor was involved in that?
Well, yeah, I mean, DelDOT procured it. Recce, Italian contractor,
Oh,
built it.
okay.
Yeah.
Okay.
And I was with Figge Mueller at the time, and we
Oh,
were the
you were
engineer
a
of
figure at
record.
that time.
Yes,
Okay.
yes.
Yeah, that's interesting. I also saw that. So when was the first cable stay structure built in the U.S., by the way?
In the U.S., well, don't hold me to this because I'm biased, but I'd like to think Sunshine Skyway Bridge in Tampa.
Yeah.
John Mueller had done a similar one in France, Breton, and he brought that technology to the U.S. and he and Gene Figg formed a partnership. So I want to say Skyway, but I'm sure somebody at at Parsons or DRC might challenge me on that. But certainly Skyway would have been one of the first back in the early '80s. Yeah.
Who are the really well-known designers for cable stay? I know cable stay are beautiful bridges. I love those. They look really fantastic, particularly going over the bridge. It looks like a sail bridge, right? Sort of,
Yeah.
we call them sailing bridge, right? Uh,
Yeah, they are beautiful structures. I mean, there's a number of companies that do them. AECOM, we've probably have about 30 in our portfolio right now.
oh, yeah.
A lot of it's through aggregate firms that we've acquired over the years. But just for example, we're doing Gordie Howe International Bridge right now, which will be the longest cable stay span in North America when it's finished and be done in May. So we're pretty close.
Oh,
Where's that
yeah.
one?
Detroit,
Oh.
Michigan, crossing over into
Canada?
Windsor, into Canada. Yeah,
Oh, wow. Wow.
Wow.
Ontario. So certainly AECOM. URS through
Mm-mm-mm.
Griner,
Right.
now an AECOM family
Right.
company.
Right.
Monsell, Faber Monsell, all now part of the AECOM family. But beyond that, Parsons, uh, you know, Parsons Brinkerhoff, which is now WSP, although they
WSP.
really don't do a lot of it now.
Right.
In the early days, I'd say with Fig and Mueller, it was us and Dr. Tang with DRC
Right. Right.
before T.Y. Lin bought him.
Too well, then, yeah.
And probably Parsons Brinkerhoff. I'd say those were your top three who were sort of paving the
Pioneering.
way for the technology.
Mhm.
And now there's more folks involved, but those were the primaries. So
Right.
so T.Y. Lin, right, still does it, and of course I think Dr. Tang's still practicing, believe it or not. So
That's right.
yeah.
That's right. I've seen him, but I have not been introduced to him. Right.
Yeah. So, complex bridges is where you specialize, and these require you to plan and design around specific topography and different elements, as opposed to just standardized sizes and precast structures and things like that. So, what was one of the most notable features in your career that you had to design around? Does anything come out in your mind as that?
Well, that's a good question. I mean, they're all challenging. They all have different things that the geometrics in large measure dictates the structure type because it dictates the span. What do we have to span? Is it a navigable waterway? Is it a railroad yard? Are they utilities? Um, and every job has those. Um, the one we did in Washington D.C., the Frederick Douglass Memorial Bridge, kind of an interesting one because the the geometrics of it could have been just a normal urban city bridge with multiple piers in the river and really utilitarian.
Mm,
But it's the nation's capital. A lot of cities we work in, they want a stamp, that
yeah,
reflects their culture and their,
Yeah.
who they are at this time, and
yeah,
so Frederick Douglass was no different. It also had Frederick Douglass's name attached to it, which was an important historical figure. And so that one, because not much navigable anymore, the Navy Yards there, which was like the largest munitions base in the world for a long, long time, but they no longer run ships up through there. So it's really just sailboats. So it wasn't really a navigable thing, but the department wanted minimum only two piers in the river. And they wanted you had to land it on either side, right? You're dropping right down in where the two stadiums are, Washington National Stadium and the new soccer stadium.
yeah.
So you're pretty fixed there. But the challenge for us on the other side, there were huge sewer lines. And I don't remember I mean, you're talking like 1 million gallons of sewage a day that's pumped through um, very old and brittle 108-inch diameter forced main. And it had already failed a couple locations in the city, and it all
Wow.
gets pumped to White Plains. And the concern is that because of the brittle, fragile nature of it, and we had huge pipe pile foundations, the
Mm.
way the arches work, our abutments were thrust abutments. All the load was coming into those abutments. You can imagine the load there, and we had this 108-inch line within 6 feet of our footing and our foundations.
Wow.
So we had to do a lot of strengthening and bridging over and around, still making it so that it could be repaired in the future, and a lot of monitoring during our foundation installation. That was probably one of the biggest challenges. Most of the time, we can avoid it. We would have just put a jump span in the back and jumped over it. But because of the locked-in geometrics, we had to deal with it. And no one wanted to pay to relocate it because
Yeah.
of the multi-millions of dollars that would take,
Yeah.
or even line it. So that probably, whenever you're locked, and you can't just design around something, that's when it becomes challenging.
Yeah. And especially when you design complex bridges, it really gives you an opportunity to show the best of your work, you know. And yeah, the Frederick Douglass Memorial Bridge is a beautiful project. I mean, that's one of my favorite pieces of
Yeah,
infrastructure.
I was
Yeah.
just driving down
Thank you.
here to Richmond last night, just admiring it. It was perfect coming down the interstate, and the moon was right behind it. And you see the beautiful
Nice.
arches all lit up. And yeah, I had the opportunity to do some inspection work there while they
Okay.
were building it. So we've been doing testing on it for a few years.
Okay.
To see that come from the ground up, from the piles is pretty amazing. So yeah, it's quite a bridge that we have there.
It was a fun project. Yeah, I forgot you guys were involved with the MIC testing, right? And
That's
Mhm.
right.
yeah,
That's right.
yeah,
I'll
yeah.
tell
That
you
was
what.
another challenge that comes around that you're not aware of. But I'm
eh,
sorry, say again.
I tell you what. You guys have used the coating on those piles, steel
Right?
piles.
Yeah, the coal tar
Uh,
epoxy.
Coal
Yes.
tar epoxy, that has saved that
Yeah.
footing, because when we did the analysis, we're still working on it, because Richard said we want to get an 8-year study on this. We were initially putting it for 2 years and say, you know what, there's no corrosion, just close it. We don't want to waste our time and money. He said, yeah, Siva, good that you really want to save money, but we got all these coupons. We want to study it and go back and do the study. And I said, we will. But we looked at it. Regular plain steel is corroding at a much higher rate, and then the coated steel really have no corrosion at all. It's like
Yeah. So here's the backstory on that one. So that was design build. So it was best value with an aesthetic part. We had to basically we had a blank canvas, right? We could design and create anything we wanted, and we looked at a lot of things. I mean,
Yeah.
well, I started with about 30 different options, cable stayed, arches, really
yeah,
kind of went back. I was born in DC, grew up right outside of Washington D.C., so always loved the city, the architecture. It's a city of arches. Kind of came back to the roots of that, but I really wanted to modernize it. And so it took some morphing, but eventually what you see today is what was created. But the backstory on the steel, so we're going in, so as we're trying to win the job, it's a bid component. It's a lot of different components from a best value standpoint, but also the aesthetics. Bid component, we said we're going to use steel pipe piles, like 60-inch steel pipe piles. And there was, no indication why not, right? You can use, they're heavily loaded piles. You can use drill shafts, you can steel pipe piles. You're pretty limited in type of deep foundation for a structure of that magnitude. So we go with steel pipe piles. We win the job. We advance it past 30%. We're moving towards 60% design.
yeah,
In the project office, this was a project office project, department gets wind from the railroad that they have a problem on one of their bridges in this MIC. It's microbial
oh,
bacteria. And, well, I didn't even know what that was. And so it's a good lesson because I will say this, I stay in my lanes. I know what I know. I'm good at what I've practiced at and what I've studied, what I've experienced. But this was beyond my expertise. And as you research it on the internet, there's not a lot of examples where there was a problem, and there's
right,
only a few. So I called the National Steel Bridge Alliance and I said, I've got a problem. Who would you recommend to bring on? And they recommended a company out of Austin.
yeah,
Some professors at, I guess, formed a company out of University of Texas, Austin, and they were great. They knew exactly what it was.
yeah,
They could define it. They understood it. They told us what to sample, how to look at it, and then they made a recommendation, two coats of coal tar epoxy. We had already had I think it was a half inch. It was either a quarter inch or a half inch sacrificial
okay,
thickness on the steel pipe pile. We knew it was going to corrode over time, just not
not
Through
through
the
mixed
aggressively.
not
level
through Mick.
corrosion.
Yeah. So we have that, but then they recommended the coal tar epoxy, and they recommended after driving to go in and with divers to make sure it was all
Good.
buttoned up. Yeah. So
Yeah.
It's good to know that it's performing well. It's
That's
a
great.
relief. Yeah.
I wanted to
Yeah.
get the backstory. Did
Yeah.
you know before you actually put it
No,
down
we
there?
did not. We did not.
And
We would have been nice to, but
and
yeah,
that's the only solution that's really going to work for that. Additional thickness could be gone because it's got to be increasing so much
yeah,
more, or even any other mitigation methods may not work because this bacteria, once it forms, it hides
yeah,
underneath and keeps eating and generating the sulfuric acid. This
right.
kind of keeps going
Yeah,
forever.
yeah, it's bad stuff. And
Yeah,
you can imagine a design build project where we're almost at 60% design. Contractors already, they're already in their procurement phase or their fabrication phase. They're advancing, taking some risk because we don't have, stamped engineering drawings yet. But pretty much everybody we knew how many piles, we knew the lengths, we knew the diameter, so we were advancing. And if we had to change to like drilled shafts or something, it would have been might not be open to traffic today.
Yeah.
so what happens in those situations? The contractor would have already locked in the price because you're actually working on the
Yeah.
job. So when you have to quote all these things, wouldn't that be extra? How does that work out?
I think if we hadn't found an amenable solution that we all could be comfortable with, because listen, as the EOR, I'm not. Everybody's concerned about the money and the schedule and all those things. I don't want to diminish that, but as the EOR, I mean, right, our job's primarily,
Make
not
sure it's done.
primarily, but our priority is public safety, and
Right.
the structure will last as it's designed and its intended use for the loads. So, we wanted to be really comfortable with it. Obviously, the owner did because they own the asset,
Right.
and the contractor too. I wouldn't want to diminish that they don't care, but um, so I think we found a good solution. If for some reason people had gone to their corners and said, no, we want a different foundation type. Yeah, you're right. It probably, we probably would have proceeded, not probably, we would have, and we would have redesigned it, but it would have probably still been in litigation today.
Right.
So there, the contract, everybody would have, again, gone to their corners and pointed fingers, and somebody would have said, this clause in the contract protects me, and this clause protects me, and
Right.
who's paying, right? Who's paying for the
Ultimately, yeah, you don't want to
millions
lose
and millions
money.
of rework? So yeah,
Right. Yeah.
it can be stressful. That's why my hair's white.
That's right. We all have to eventually
Yeah.
work together to get this done.
Absolutely.
But at the end of the day, everybody has to pay the bills too, right?
Yeah, those are the best kind of projects.
Yeah.
The
Yeah.
ones where everybody has same
Working
goals,
together.
and they want to work together.
Yeah.
That creates a whole different environment on a job.
Yeah. I was involved with the New Nice Bridge.
Yes.
I was so surprised how fast it went
Yeah.
from design to opening, and that was amazing. So I'm sure the cooperation among all the parties was there really well.
That's a 5-star example of how a job should run. Owner's engineer, design engineer, in this case was us, and then the contractor, just great partnership.
Is it?
Yes, everybody really in lockstep, and it was a pleasure. Yeah, you said I've been at it for 39 years. I probably worked on 35 major projects, over the years because they take a long time to deliver.
Mhm.
Um, and on my one hand, I can count the ones like Harry Nice that everybody was just cooperative and wanted the same thing. Everybody wanted success.
Right.
Makes a big difference. And it makes for a pleasant, you enjoy going to work every day, those kind of jobs.
Yeah.
Yeah.
I'll tell you, I was very, very pleasantly surprised by how well it went, and I really appreciate working with AECOM and the whole group. In terms of how it went.
You guys did a great job for us.
Oh,
Really good.
Thank you.
All
Thank you.
concrete structure in a corrosive environment.
Yeah.
And we had to prove out 100 years. You guys really, really helped.
Yeah.
Yeah, so
That's great. I mean, Will Pines told me, after a while, you guys did a great job, and if you want any recommendation, let me know. I
Yeah.
was like, that's great.
now the owner's very happy. Yeah, we
He
all
was-
are. It's a good looking
He
bridge.
was very
Yeah.
happy with that. To the point that he actually wanted to come and do the presentation with me at the Northeast Bridge Conference.
Yeah.
And then they wanted me to repeat that at the Western Conference. Do you think I can drag you down all the way to the Western Conference? He said, I would love to, but I don't have time.
Yeah.
And now he has become big. Like he's the commissioner of SHA now.
Yeah. He's the top guy.
Yeah.
But again, that shows you, those as you develop those relationships on these jobs, and they benefit you through your
Right.
career.
Right.
Will's a friend, and he has been for years, and through
Yeah.
his growth, through his own career.
When did you first know him?
Oh, I met him. It's probably 10 years ago or so.
Yeah. When he was at MDTA?
Yes, and even before Harry Nice came out, I met him actually he asked me to come. I think it was on Indian River when I met him up in Delaware,
Yeah.
and they were thinking about going design build on Harry Nice, and I
Mhm.
actually would drive across that Harry Nice on the way to because I had again project office. I was up there every week in Rehoboth, and so I would drive across Harry Nice Bridge, and I remember calling Skanska. This was probably in 2007, I guess.
Oh, wow.
And I
That's
said,
long ago.
"Hey, we need to. This thing's going to be coming out in the next 10 years. I want to team with you guys on it. So let's keep this on our books." And so that's how it started. But then when we were doing Indian River, Will came out to the site, and they were thinking about going design build. And at the time, the channel on the Potomac was such it would have required a cable stay.
Mhm.
So he eventually brought me in for a design build workshop, and then he brought in, like all the cable stay bridges that were going on at the time around the country. He brought in the key people for those, and we had a full day workshop and lessons learned, and maybe what you do different. And then through the years, like before Harry Nice came out, I called him and told him that I would think about materials like in the deck, chromium base reinforcement, for example,
Yeah.
opposed to an epoxy coated. So you kind of, as you develop trust with each other, you can share what you've experienced, what you think would be the best
Yeah. Yeah.
use of your money and your materials. So
Right. That's great. When was your first design build?
first one,
And which one was it?
probably Trent Urbano in San Juan, Puerto Rico.
Oh, okay.
We had it's almost 10 miles of elevated precast segmental viaduct.
Oh, okay.
So we were actually we were on the owner's side, which is a rarity for me. Normally, I'm on the contractor side designing, and we were overseeing that work. We developed like 30% design, and then the design build package procurement, and then help the owner put it out to bid. So that was the first one. But then the first one I really worked with contractors, joint venture Flatiron and Skanska, was Carolina-based Parkway in Myrtle Beach, South Carolina.
Oh, okay.
There's like 23 bridges on that one.
Oh, wow.
Wow.
Okay.
And that was back in 2002, I think. Yeah, something
Mm-mm.
like that.
Okay. So it's been going on for quite a long time.
It has cable stay bridges, up until about 2006. I'd say 90% of the cable stay bridges work I did was for the owners, design, bid, build.
Mm-mm.
Today, it's flipped. It's 90%
Design.
alternate delivery, 10% design, bid, build. So the owners have shifted to alternate delivery, whether that's design build, progressive design build, CMGC, whatever format that takes. But yeah, so yeah, I'd say 2006, and for the young people, I think that will be that's the movement forward.
So they are moving towards alternate delivery method, most of them.
For complex bridges, yeah, it'll be in one form or another. So the Brent Spence Bridge I'm working on now in Cincinnati is what they call progressive design build.
Yeah. Yeah.
And that's a little nuanced. So if the owner has, like Frederick Douglass has a set alignment, set profile, maybe we tweak it a little bit through design and ATCs, but it's pretty set. The environmental document's done, the rod's done, everything's kind of buttoned up and locked down. Or like Harry Nice, everything was, in place. Those are easy to go design build. I think from the owner's perspective, they get the best value for their money. They shed risk, right? Risk goes onto the design build team for the most part. They improve their schedule because we're moving really fast. You could see with the 2-mile long Harry Nice Bridge, right? We designed and built it in like what, 2.5 years.
2.5 years, yeah.
In the old days, in a design bid build world, that would have been a 4-year process. So,
Right.
definitely a 1.5 year acceleration. So, but on a job where everything's set, design build for Cincinnati and Brent Spence, there's so much undefined. And so we're going through and working with the owner. And a Progressive, the owner picks a design build team, just like they would under a normal design build format. But then the owner's part of the design. So we now work together. We've been working together since October, refining the alignment, refining the profile, going through innovations, trying to find ways to save money on the job, going through the environmental document, the permitting document, right? All the Corps permits, the Coast Guard permits. So we are essentially Progressive design build almost kind of meshes preliminary engineering and final engineering and the contractor all together. And so it's a little different process, and it gives the owner and the design build team off ramps at several phases. We'll hit our first phase, what they call phase 1A, in November 15th, which will be a 30% design.
Okay.
And in a what they call an opinion of probable cost. So the job is targeted about $3.5 billion. Let's just say it comes in at $8 billion. Well, the owner gets the opportunity, to say we're out. Or they get the opportunity to say, all right, what are we going to do to get it back down to 3.5? Now, if it comes in at 3.5 and they're happy with that and they're happy with the way we've done the work for them, then we'll continue. They'll give us another advance to go to 60% design. And then at 60% design, there's also an off ramp for both parties. And if we stay on the ramp, which, all expectations we will, then from the 60% to RFC and build is what they call GMP, guaranteed maximum price, goes to a lump sum. And then you're off to the races. Then it's almost back to a conventional design build format. You're really running to try to get it open to traffic. So
Gotcha. So in the Progressive design build, if I may, for the ease of others who are not in the industry, if you want to compare that to cooking, the Progressive design build is getting all the ingredient weighed and measured and ready, and then you have the actual cook and the helper to make sure that it's all put together right.
Yes.
So the weighed and measured part of it is the Progressive design build initial phase 30%.
Correct.
And then the 60% is actually getting all those things into the place, and then 100% is actually finally designing and putting it in place and opening traffic. Okay.
Yeah.
How does the funding work for the 30% and 60%? It's still nothing in the ground, right?
It's nothing in the ground. And I don't think, the contractor would love early works packages to help them with their ultimate schedule. That, I don't think the owner will release any early works packages until they hit the 60%. And if they keep on the on-ramp, then that's when they'll release more money to do construction, to the benefit of the project. Because at that point, they'll have a comfort level. They feel good about the job. It's moving forward. The design they're more comfortable with advancing because, in their terms, they consider that a benefit that they can use. In other words, they won't lose that. If for some reason they decide to take the off ramp, that's still salvageable, right?
Right.
That's
That
all
30% you can still
correct.
use.
Yeah. But let's say a foundation in the ground or wall built, that may or may not be
Right.
salvageable to them in their mind. So yeah, so that's why it's progressive. You'll see, yeah. So
So they assign some money for that initial design phase,
correct. So they've
and
been
they require that.
completely funded for the 30% and the 60%.
Okay,
And
gotcha.
then once we get to 60% and the contractor gives the GMP, then the rest of the funding will come in. Yeah.
Okay. What's GMP, by the way?
That guaranteed maximum
Oh, I
price.
see.
Yeah,
Gotcha.
yeah.
Gotcha.
Yeah, a lot of acronyms to learn
I
on the
know.
progressive
I
design
know.
build.
I was thinking you said about this CMGC and
Yeah,
a
yeah,
number of things, the alternate delivery method.
right.
I know you explained this progressive design build really well. For others who are in the industry, they know, but some of the other people who are listening, they may not know. So can you explain a little bit about the alternate delivery, what all includes, PPP, design build, design bid build? Just quick, brief explanation would be good.
Okay. I guess for the folks who don't understand alternate delivery, think of it like a toolbox. And there's just different tools. There are different procurement methods. There's design build, which the owner, again, has a project that's pretty defined. He solicits for a design build team, which is a contractor and an engineer together. It's through a shortlist process based on qualifications.
Yeah.
Have we done it before? Have we done it successfully before? Have we done it successfully together before? Will the owners give us good references, right?
Right.
All of those check, check, check. You're shortlisted. Typically, they shortlist 3 teams for the size projects that I do, and then they have a really well-defined, stringent set of performance specifications, technical specifications, and you bid the job. And that RFP phase is, again, best value. Sometimes there's a schedule component. There's always a cost component. There's a technical component. A lot of times it's like 60-40 or 70-30, meaning 60% technical, 40% price, or vice versa. Some states are just low bid, so there's all kinds of methods you can do in design build in the way of pricing, best value. So that's that. CMGC is versus CMAR. There's a couple different ones, but basically it's construction management at risk. And the way that works is the owner selects an engineer, again, based on qualifications, and then they select a contractor and they force them together. It's a forced marriage between the contractor and the designer. And then they progress the job similar to a progressive design build.
Mm-hmm.
The variance with progressive design build is the designer and the contractor form a team just like they do in design build.
Okay.
Okay. And then the owner selects that team the same way they would design build based on qualifications.
Right.
And then the 3 move the project together. So the difference in CMGC or CMAR and progressive is simply who hires the engineer.
Okay.
From my perspective, I rather pick my contractor partner. I mean, there's probably, for the size projects and the complexity of the work we do, there's less than a half a dozen contractors that we trust, that are like-minded and have similar culture,
Right.
and vice versa. Heavy civils are pretty particular too, contractors. So we prefer to have our partner. We'd like to pick our partner as opposed to the owner doing it.
Right.
So that's a little nuance. Then you've got 3P, you mentioned, public-private partnerships.
Right.
And that's even different. That's when an owner has a facility that they know they want to build. They really don't have the funding for it. So they allow industry to come in and develop a toll revenue scheme. like in Virginia, the hot lanes, right?
Right.
And then there's a term limit associated with that facility. So the owner may say they call it a concessionaire, who,
Concessionary, yeah.
because the concessionaire, the people with the money control everything about the project.
Okay.
And the builder is secondary and the designer is like, always equate like, in a design build, the designer's in the back seat. In a 3P, the designer's in the trunk, right? We're not, the person who has money controls. And so the toll revenue schemes developed to say, hey, we can generate enough toll revenue to pay for this facility. The concession needs to be over a 40-year period, a 50-year period, whatever it is. We need to have this facility for 50 years to make our money. And then we'll turn it back over to you in a defined condition. We'll have to maintain it, operate it. And there's variances of that. Some owners don't want to turn over operation and toll collection. Some do. So there's all kinds of within the 3P format variations, like the design, build, own, and maintain.
Mm-mm.
There's design, build, finance. There's design, build, availability payments over 5, 6, 7 years, and then we're out, and then the owner takes over. So all kinds of variations within that sort of finance mechanism.
But ultimately, the owner was responsible for all the finance, even though the money is coming from somebody. How does that work? Really?
Well, these large 3P jobs, there's lots of things. There's grants, there's TIFIA loans, there's different mechanisms of finance. I'm not a finance guy, but just from what I glean when I'm working on these jobs. So there's different revenue streams. But ultimately, it's the concessionaire who's funding the project. Now, again, there's some influx of money, but it's not like, let's say the hot lanes, I don't know what they were. Let's just say they're $2 billion. The TIFIA loans and the grants aren't coming up with $2 billion. It's a little chunk of it. But the concessionaires, from my understanding, finances it and then collects their money back over that 40-year, 50-year concession period through toll revenue, including escalation, profit, interest. There's a whole
It's all built
financial.
into
It's all
their
baked in.
model.
Yeah.
Yeah.
So
So when you do the design build and you give the cost, but it takes what, 3-4 years? Brent Spence, for example, you say it's going to take a long time to build.
yeah,
How do you build into that? How do you estimate what the escalation is going to be? Inflation is going to be, whatever.
it's tough.
Yeah.
Yeah, we were talking about that yesterday. So I was in Cincinnati yesterday for our meetings, and cable stay came up, and how do we give you a price now when we're really not going to start building the bridge till probably 2028,
Yeah.
maybe 2027, but it's still a good ways out.
Right.
So yeah, those, I mean, I won't say we have it all figured out yet, but you're
Yeah.
right.
I always wondered about that.
Yeah.
Yeah.
On,
So-
on those public-private partnerships, and you said that the people with the money get to drive the project, which makes sense, right? If
Sure.
you're financing it, but does the state still retain control over what the design standards are as far as getting a quality
Absolutely.
back at the end when it's delivered back to them?
Absolutely. The owner is still very much entrenched in the delivery process, and they have an owner's engineer. So on the Gordie Howe International Bridge, and that's a really a complicated one because, well, it's an international crossing, so you can imagine you're dealing with the customs, 2 countries, both countries, different specifications,
Sure.
different standards,
Different
but
units.
we have to conform. We have to conform to all of that.
How do you do that?
And
That'd be interesting.
yeah, it gets a little messy, but essentially it had well, I don't know. I won't get into it. It gets a little complicated, but I would say this: yes, like when they did the hot lanes, let's say the roads and the bridges, all had to be done to AASHTO standards, all had to be done to VDOT. standard
Right.
specs, guidelines um, in the department because they're essentially leasing
Hmm.
the facility, but they still own it. And they're very much engaged and in overseeing and making sure that, I mean, again, their role is public safety
Yeah.
and responsibility, so that happens. Yeah.
So, does they ever have a chance to be, for example, concessionaire who's supposed to maintain and do all this work for 40, 50 years? Has it happened that they've done it? This is a relatively new model, right?
No, 3Ps have been around for, I don't know, at least 20 years.
Okay,
Um,
but
and they've been done a lot overseas, like um, Australia does a lot of 3Ps, and
oh, really?
yeah, so I think it's a pretty, I think it's a good model. I think, um, yeah. Again, I'm outside of my depth here a little bit, but
Yeah,
so what I'm sharing is really just what I've experienced, but not necessarily in my wheelhouse.
yeah.
But yeah, I think it's been around a long time. Now, how many facilities have hit the 40-year concession and been turned over to the owner? Yeah, I don't know about that. I know some facilities have been turned back over, and sometimes owners take them back over because maybe the toll revenue's not what was expected to be, you
Yeah,
know, that kind of
yeah.
thing.
So the
Um,
concessionaire walk away and
yeah.
lose all their money?
Or no, they're made whole, or there's some negotiation process that happens. Yeah.
I see. Interesting.
Yeah.
Interesting. Very interesting. So, one thing I wanted to ask you, I think some of the listeners may not know, we talk about complex bridges. How do you define what's complex and what's not? What decides, what criteria pushes it over to complex?
So for my practice, um, so we have in the U.S. 60 offices, about 560 bridge engineers. Canada, another dozen, other offices, maybe another 120 bridge engineers. So for my practice, the definition for all of those bridge leads who run those different offices is if the span lengths are over 400 feet.
Okay.
That's when my practice gets engaged. So for over 400 feet could be variable depth box girders, low tension box girders. It could be arches, could be cable stay, could be extrados cable stay, um,
Gotcha.
typical variations. Part of my practice does suspension bridges, so I've got a gentleman who leads that side of the practice for us. Primarily these days is all preservation and of the existing
Suspension.
assets.
Yeah.
There's a few new ones, but the ones we do new or tend to be overseas, you know,
Oh, yeah.
in Asia. Yeah.
Hmm.
So
It's interesting. I don't think we do any more suspension bridges here in the US, I guess. They moved away from it.
not so much. Yeah.
Why is that?
Well, because so when you look at the evolution of how things were, um, suspension bridges when they were built, they were really for um, span lengths greater than 2,000 feet.
Right.
2,000 feet and above, that was, you pretty much knew you were going to come in with a suspension bridge. And when you were in that 500 to 1,500 foot range, you were going to have a truss, some kind of a through truss, deck truss, arch, you
Yeah.
know, all the old vintage, right? You guys see them on every river you cross.
Right.
Harry
Mhm.
Nice
Right.
had, I think it was a 680-foot span, had that kind of
The
arch
channel
through
span.
truss. So that was the technology. When cable stay technology was introduced in the 80s, that really filled from 600 to 1,500 feet. That almost knocked out the truss and the arch because it was a much cheaper technology
Oh, really?
to build. Yeah.
Okay.
And considered at the time a much better technology because it wasn't fracture critical, right? It wasn't, you know, non-redundant, like a lot of the truss and
Trust,
arch
yeah.
structures were. And so, that really, and then with that, there was no need. I mean, you think about 2,000 foot and above for suspension. There's not usually a need. I mean, our responsibility is to get outside of the navigable limits. So on Harry Nice, it just happened to be because it's no longer really used that much. There's a vessel study done. The owner worked with the Coast Guard. They actually reduced the nav envelope from what was, I think, 650 to what we had, which was 350.
Mm,
Our responsibility was to get outside of the navigational envelope.
right.
And we tend to put the piers and the fenders right at the limit.
Mhm.
Smaller the span, less expensive it is, right? So the longer it is, the more expensive it is. So
Right.
as you're trying to win a job,
You're trying to
you're trying to
reduce
get
the
right
cost.
down, yeah. So there's just not a need for it. It would take a special circumstance where a sea crossing, like we've got one going in Hong Kong now, which it's a cross sea link, which is very difficult, and so you wanted to push the towers out to
Or,
the geology that could handle and in the water depths and so on and so forth, and outside of the tankers running, and so that required this really long span. But for the most part, you don't need it anymore. You know,
that's interesting. So your involvement as a complex bridge lead, a lot of it would be very helpful early stages when client is looking to say what type of bridge we're looking at, where what is possible, what's not possible, what is it going to cost. A lot of it will come with this basic conversation.
that's right.
You would think, yeah, that's great, that's wonderful.
And so we're helping VDOT now on the Robert Norris Bridge in West Point. It's almost identical to Harry Nice,
Yeah,
2 miles long. It had a 650, 700 foot, I don't remember, channel span. And so we've been helping them, what's the right solution there? What should they think about to get ready to procure it? Um, what kind of structures would be good to replace it with?
yeah,
You look at a lot of things, not just cost, but durability, the environment. That one's near the Chesapeake, mouth of Chesapeake Bay. It's
yeah,
pretty
yeah,
aggressive, and
yeah,
even Harry Nice was brackish.
yeah.
It's
Yeah.
8,500
yeah,
ppm, right?
yeah. So
Yeah, it's halfway to the seawater concentration. And so that's interesting. It's really good to know that the owners are actually, engaging you early stages to try to figure out what's possible, what's not possible, so that they have some idea of what kind of money they got to get.
that's right.
You know,
Yeah,
that
helps
makes,
them with their capital funding for sure.
yeah,
Um, yeah, and we bring a little different perspective because, like Harry Nice, a good example. So the owner and the owner's engineer, they thought steel spans at 260 feet were the right solution, and that's how they set the job up and permitted it and exploratory borings and all the things that go into setting up the design. But I knew I'd done so many long water crossings, and I knew that was not the cheapest solution.
mm-mm-mm.
And one of the keys for teaming with Skanska was, their marine fleet. And then they teamed with McLean and Corman, just coasting now. Between the three of them, we had the largest marine fleet on the East Coast.
Oh yeah,
And I knew there was a really good precast yard over in Cape Charles, Virginia, that was, so the whole job is accessible by barge. And I had done enough jobs where I knew that long pre-stressed concrete girder spans, you can't really use them when you have to truck them,
right, right.
to the site. But when you can barge them to the site, you cannot beat them on price. And so, I came at it from a completely different perspective based on experience than what maybe a conventional designer would look at it who didn't have that experience.
That is so good.
Yeah.
What he just said. This saves a ton of money for the owner.
Yeah.
Trying to bring that, hey, I know this would work, this would be cheaper. Let's go in that direction. from the get-go. That's a huge difference.
Yeah.
That is great. That's great. That was a really good bridge. I was glad to work on it with you. And you guys have any other thoughts you
Yeah,
want to
so
close
one of the
out?
things that I wanted to just go over with you is you've had a expansive career that you've done a lot of incredible projects. Did you end up starting your career in the complex design build sector, or did you start somewhere else and kind of transition into what you've
Good
built
question.
your expertise in?
Yeah. So I graduated from University of Maryland in 1984. Um, my study was focused on structures and bridges. Time Maryland, and I don't lost touch, but I just a couple of really good bridge uh, engineer professors, and that's what I always wanted to do. I mean, from you know childhood, that's all I ever wanted to do. So I had a passion for it, right? But when I got out of school in Maryland, there was no bridge work being done. So I hired on with a geotechnical firm, and I learned deep foundations for 2 years, just good. Um, because it did, that wound up dovetailing in the. I'll digress for a minute. We win and lose our complex bridges, to be honest, in the foundations. Most of the time, the cost of superstructure is pretty close, depending on the different types of superstructure. It's the foundations we win or lose jobs. So that it helped, but I never lost sight that I wanted to do bridge engineering. And you got to imagine in those days, and you'll appreciate this because you remember, you didn't have the internet, you didn't have. So I saw an ad in Civil Engineering Magazine, which was our probably only go-to,
Yeah.
and the ad in the back was classified, and there was literally a postage stamp size ad for Fig and Mueller um, with Sunshine Skyway.
Yeah.
Wow.
So I applied, and I sent them a letter. I got a letter back, Federal Express, with airline tickets to come down for an interview. That's
That's
how it's done.
amazing.
It's kind of funny. You think about it now, home landlines and no cell phones and no internet. Um, and then, I don't know, 3 weeks later, I was shoveling out of 18 inches of snow, and my wife and I were moving down the Florida Keys because there was 7 Mile Bridge and
Mhm.
Long Key Bridge were going. And
Well,
yeah, so it was awesome. So, but the first couple years, I was doing foundations. Yeah.
And I
geotechnical.
love how when you described the first couple of years when you started learning foundations, you didn't say I worked in foundations. You said I spent the time learning it.
Yeah.
And I feel like that's one of those things that the younger people in my generation, they kind of lose sight of, that it's not a job, it's an opportunity for you to build yourself and
Yeah.
build your skill set. So I really
100% agree.
appreciated that
Yeah.
when you said that. So another question that I had for you is, you're currently working on the Brent Spence Bridge in Cincinnati over the Ohio River. Um, that's a massive project. It's a $3.2 billion project. Is that one of the biggest projects you've done, or is there anything that tops that?
No, it's the biggest project I've done.
Yeah.
Life's funny. I think about, I did a job in Miami back in the mid 80s, and it was built for, let's say, $63 million. It wasn't quite as big as Brent Spence, but it was 80% of it. But an order of magnitude, so in other words, yes, it's the largest project I've worked on, certainly monetarily, and to some degrees, even the components. But a lot of the jobs over the years have been very large, just like that, but not, like in today's money, they would be similar in
Right.
size. I guess what I'm
Yeah.
trying to say. Does that
Yeah.
make sense?
Yeah.
Yeah.
Because everything costs more as time
Yes,
goes
yes,
on.
yes, yes.
Right. Yeah.
Yeah,
Interesting.
Yeah, including infrastructure.
yeah,
It goes down to every aspect
yeah,
of society.
yeah. Escalation's an amazing thing.
I
So,
know. That's one thing I ask all the time.
yeah,
How do you give a price that you're gonna hold on to it
yeah,
7 years later,
It's
right?
yeah. It's
difficult.
tough.
Yeah.
Yeah.
That's why we're engineers, not contractors.
That's right.
Of
That's
course,
right.
they have it figured out because they do pretty well. So I'm not feeling sorry for them.
Yeah. Yeah.
I don't know how they do it, but they certainly get it done. Thank God for that. So you want to say something about any awards you won? I know you got some. I know that. You want to share some of the things, like one thing that some of that stands out in your mind.
You know, yeah, I guess. I mean, listen, we're fortunate because of types of bridges we do. They showcase themselves well to
Right.
win a lot of awards, and we're really happy to do that for our customers. We really, um, I'm fortunate because I get to work with a lot of different state DOTs, different contractors, and it's fun. But a lot, like you think about a DOT, they might, and once in their career, have a Frederick Douglass, right? Another one might not come along in their career
Right.
because they're just unusual projects. And so it's fun to be with them and like get the awards and, get them the credit that they deserve for,
Yeah.
getting the project launched and seeing it through and, all of the backdoor things that take place for them to move a project forward. So I like all of that. For me personally, it's really about that. The exception of one maybe sticks out. Recently on the Frederick Douglass Memorial Bridge, actually at the International Bridge Conference last June, um, I received the Eugene C. Figg Award
That's
uh,
great.
for the Frederick Douglass Bridge. So personally, it meant something because I'd worked for Gene
Good
Figg,
morning, Adam.
and it kind of
Come join us.
brought it all home to me. So yeah,
Right.
That's amazing.
yeah.
That's great. It's just so good to have you here, Ken.
Well,
And
thank you guys for having me.
we haven't finished half the questions, so we may have to bring you back another time.
Happy to do it.
And it's great to have you here. Thank you so much for
Yeah,
coming and
thank you
joining us.
guys.
We really
Appreciate
appreciate
your time.
you spending the time.
Absolutely.
Yep.
All right,
And
gentlemen.